Lesson 10, Nesting and Decoiler Output. Autodesk Fabrication CAMduct can arrange the flat patterns to be cut from a piece of sheet material for maximum efficiency and minimal waste. This process is called nesting and can be done on the desktop or by using the Autodesk Cloud Nesting Service. Fabrication CAMduct can also send NC code to decoiler units to fabricate full-length straight ducts. Fabrication CAMduct offers both automatic and manual nesting options. The automatic nesting functionality uses pre-configured settings and options to simplify repetitive tasks and enables the software to determine best fit options for the nested parts. Fabrication CAMduct can interface with and control a wide range of machines used in the manufacturing and production of ductwork and sheet metal components. It can work with burning tables such as plasma, laser, and oxy-fuel tables. It can also work with decoiler units and insulation cutters such as water jet, router, and tangential knife units. Configuring Fabrication CAMduct to properly communicate with these machines is a specialized skill that is typically performed only when a machine is acquired or modified. Machine setup varies for each make and model and is not included in this course. However, generic machine and decoiler unit setup processes are included to explain the concepts of machine configuration and to support the nesting exercises in this lesson. For this lesson, you'll do the following. Configure a basic machine and decoiler unit. Learn about automatic nesting. Understand how to nest metal and insulation. Write NC code files for machines. Learn how to handle oversized parts. Use the Autodesk Cloud Nesting Service. Understand how to output to decoiler units. Start Fabrication CAMduct. Select the Imperial Content configuration and open autonest.maj from the exercise folder. Improper machine configuration can, by causing the moving parts to act in unexpected ways, damage the equipment and endanger people. The following steps create configurations which are suitable for this tutorial only. They are not intended for production use. Always consult the equipment vendor or supplier or retain an experienced consultant when setting up machinery. From the File pull-down menu, select Setup and then choose Installed Machines. The Installed Machines window appears. Along the top are tabs for various types of machines. This exercise focuses on creating a flatbed cutter configuration for a plasma table. Within the left pane are the configured flatbed machines. Fabrication CAMduct has a default configuration for a plasma table. Along the right side of the window are buttons to create, modify, and group machine configurations. Highlight the default machine configuration and select the Setup button. The Machine Editor window appears. The tabbed interface displays settings for various aspects of the machine. The Machine tab is the default view. The name of this configuration can be changed if desired. The Dimension settings define the size of materials that this table can accommodate. The rail axis is the lengthwise dimension of the table and is typically 120 inches or 240 inches. The beam axis is the width of the table and is usually 60 inches. Sheet materials of metal or insulation are usually purchased in standard sizes of 60 inches by 120 inches or 60 inches by 240 inches. The Restrict Nested Material Sizes setting prevents the use of larger sheets on this table. This setting is not necessary if materials have sheet sizes defined for specific machines. The Preset Points settings define where the cutting head is located before and after a cutting operation. These also establish the orientation of the machine's X and Y axis to the NC code that is sent from Fabrication CAMduct. The Dual Tables setting enables a single flatbed device to act as two units. This is useful for 240-inch long tables, which can accommodate two 120-inch long sheets of materials at the same time. While cutting the first nested sheet, the operator can load and position the second sheet. The RIP cut settings define the final trim cut for unused portions of the sheet. For example, if a nested sheet only consumes some of the full sheet, a rip cut creates a remnant piece. These settings control whether the final rip cut is along the rail or beam, whether it is a straight cut or follows the edge of the nested parts, and sets a minimum size of remnant to preserve. Select the Controller tab. The Post Processor file determines how the NC code is generated by Fabrication CAMduct. Post Processor files are unique for each machine controller type and are similar in concept to printer drivers. Fabrication CAMduct includes a library of Post Processor files to accommodate most commonly used machines. Autodesk works closely with many equipment manufacturers and may add new Post Processor files as new and improved controllers appear. If Fabrication CAMduct does not include a Post Processor to support your equipment, contact Autodesk or your Autodesk partner. This configuration uses the D6 Post Processor file. Click the Browse button and the Select Post Processor Library window appears. The folder location is the default Fabrication CAMduct folder. Post Processor files for flatbed devices have a VPL file extension. The two most common Post Processor files are shown in the default folder, but more are located in the VPLs folder. Double-click the VPLs file folder. The Post Processor library for flatbed devices is listed. Click Cancel to exit this window. In the Machine Editor window are settings to define a prefix and the file extension for the NC code files generated by the Write NC process. The motion settings establish whether movements of the cutting head are relative to last vector. You can also specify offsets from the rail and beam edges. The NC output units settings enable Fabrication CAMduct to generate NC code in metric units if desired. The conversion multiplier can be used to convert the size. The procession of the NC code is determined by the decimal places setting. Automatic loading can be set for machines with that capability. It can be configured to stop loading sheets automatically when the material or gauge changes. Select the Special Features tab. The upper list pane displays features that are unique to the selected Post Processor file. These features may be enabled or disabled by selecting each feature's checkbox. If you change the Post Processor file, you must click OK to close the Machine Editor window. Open the configuration again for the special features to be displayed for the selected Post Processor file. Click Cancel to close the Machine Editor window. The default configuration is still highlighted. Select the Install Machines group listing above it. This deselects the default configuration. Click the New button to create a new flatbed machine configuration. A problem dialog appears warning that it cannot open the Post Processor library. This is because a Post Processor file has not yet been selected for the newly created configuration. Ignore this warning and click OK. The Machine Editor window appears with a blank configuration. Notice that the settings are blank or set to 0. Choose Cancel to exit this window without making changes. Despite the fact that you canceled out of the Machine Editor window, a blank configuration named Untitled has been created. Highlight this configuration and select the Delete button. Confirm the deletion by selecting Yes. Highlight the default configuration and select the New button. The New Machine dialog asks if you wish to copy the settings of the existing configuration. Selecting Yes can save time if the new configuration is similar to the highlighted existing configuration. Choosing No created a blank configuration, while Cancel stops the configuration creation process. Choose Yes and a configuration named Copy of Default is created. Change the name of this configuration to 20 footer. Change the rail axis setting to 240 inches. Select the Controller tab. Select the Post Processor Library dropdown and choose the Bernie Post Processor file. Bernie is a manufacturer of CNC controllers. Click OK to save this configuration and close the window. The Installed Machines window lists both configurations. Double-click the default configuration. Change the name to 10 footer and click OK to close the Machine Editor window. The green dot by the configuration determines the default machine configuration to be used when nesting. If no specific machine is defined for a nesting process, the default configuration is used. Highlight the 20-footer configuration and select the Tools button. The Edit Tools window appears. Cutting machines can use different tools. The tools that are available are defined by the post-processor file. For a plasma table, it is common to have just two tools. The first is the air plasma cutter itself. The second is a null tool. As the name implies, a null tool does nothing. This tool is selected when the cutting head is repositioned without cutting. The NC code selects the tool needed and then directs the movement of the cutting head. Some machines can automatically change out their physical cutting heads. This window enables creation, modification, and deletion of tools for each machine. Highlight the Air Plasma tool and select the Setup button. The Tools Detail window appears. These settings control movements, speed, and more. Click Cancel to exit this window. Select Close to exit the Edit Tools window. Machines can be grouped for greater efficiency. A job can be sent to a machine group rather than a single machine. As each machine completes cutting a sheet, the next set of instructions is sent to it. Select the New button to create a group. The New Group dialog appears. Name this group Plasma and click OK. The Installed Machines window shows the new group. Installed Machines is a group as well. Highlight the Plasma group and select the Include button. The 10-footer is shown. Select OK to save this setting. The 10-footer configuration has been moved to the Plasma group. With the Plasma group highlighted, click Include. With the drop-down menu, select the 20-footer and click OK. Both machine configurations appear in the Plasma group. The Installed Machines group is empty. Highlight the 20-footer configuration and click the Exclude button. The machine configuration disappears from the list. It does not appear in either group. Highlight the 10-footer configuration and choose Exclude. A problem dialog advises that the default machine configuration cannot be removed. Click OK. Highlight the Plasma group and select Include. Choose the 20-footer configuration and click OK to restore it to the Plasma group. You now create a machine configuration for a water jet to cut insulation. Highlight the Installed Machines group and create a new machine configuration. Ignore the post-processor error and click OK. The Machine Editor window appears. Name this configuration Water Jet. Enter 120 for the rail axis and 60 for the beam axis. Select the Controller tab. Click the Browse button to select the post-processor file. Double-click the VPLs folder. Scroll to the bottom of the file list and select watergen64.vpl. Click OK to use this post-processor. Select the Special Features tab and note that this post-processor file offers none. Click OK to save this configuration. The Water Jet machine configuration appears in the Installed Machines group. Create a new group called Insulation. Move the Water Jet configuration into the Insulation group. You must add tools for the Water Jet. Highlight the Water Jet configuration and select Tools. In the Edit Tools window, choose Add Tool. The tool type displays the default choice for this device. Select the drop-down menu and examine the available tools for this device. The Water Jet tool is the appropriate choice. Click OK to save this setting. The Water Jet tool appears in the Cutting Tool group. With the Water Jet tool highlighted, select the Setup button. The Tool Details window appears. Notice the extra tab in the lower pane. This post-processor file includes additional parameters for corner slowdowns. Make no changes and click OK to close this window. The Fill Missing Tool Data setting should be enabled as Auto. As the setting name suggests, this fills in any missing parameters for this tool. Click Close to return to the Installed Machines window. Select OK to save these changes and exit this window. You now configure a decoiler unit. On the File pull-down menu, select Setup and then choose Installed Decoiler. Installed Decoiler window appears. Select the Decoiler Processor File drop-down menu. Only one post-processor, the generic decoiler processor, is listed. To locate additional decoiler processor files, select the Browse button. A Browse window appears. Unlike the previous steps to locate a VPL file, the Browse window does not open in the Fabrication CAMduct folder. Browse to C, Program Files, Autodesk, Fabrication 2015, CAMduct, DPLs. Select iowa64.dpl and click Open. Iowa is a common decoiler controller. Name the configuration Iowa Precision. The output file location can be specified here or can default to the location set in the Imperial configuration. Accept the default, which is Use CNC folder. The CNC file name can be specified or automatically names using the job name or an incrementing number. The file extension can also be set. Accept the default's file name settings and click OK to save these changes. Select Job Contents and scroll to the top of the list if necessary. This is a supply air duct run containing about 100 items. Some of the fittings and straights have internal insulation. Notice the column named Nested. The number of nested parts is shown along with the total number of parts for this item. All items have no nested parts. For this exercise, you must change a setting in the database to enable cutting for insulation. Select the Database button on the utility bar. Click Fittings and select Pattern Switches in the left menu. Select the Developments tab. Enable the Cut Insulation option if it is not already selected. Click OK to save this change and exit the database window. You must also change a setting about how non-standard straights are cut. Straight ducts that are intended to be sent to the decoiler unit have their machine cut type set to decoiler. But if these straight ducts are not full length, they do not qualify for the decoiler unit as the decoiler cannot handle straight ducts less than full length. To see the item's machine cut type settings, right-click on the header and choose Customize. Highlight the item quantity length print object in the right pane. New print objects are copied and inserted above this highlighted print object. In the search filter field above the left pane, type Cut. Select the item cut type print object and click the right arrow button to copy it to the right pane. Select OK to save this change. The Cut Type column appears in the Items list. Scroll to the top of the list and click on the Cut Type column header to sort the list by cut type. Machine cut items are shown at the top of the Items list. Resize the columns to better see the data. Scroll down to the first item with a cut type of decoiled straight. Most of the decoiled straight items have a quantity of 56.25 inches. These are full-length straights and qualify for the decoiler unit. But a few items are shorter. Look at item 1107 for example. Its quantity or total length is about 46 inches. This is called a non-standard straight, as it is set to be cut on a decoiler unit but doesn't qualify for the decoiler. Non-standard straights must be nested and sent to the plasma table for cutting. The setting for this is in the database. Click the Database button on the utility bar and choose Fittings. Select Pattern Options in the left menu and choose the Straight tab. Scroll to the bottom of the list and locate the setting named Machine Cut if cannot decoil, Non-Standard. Enable this setting. Any non-standard straights with a machine cut type of decoiled are nested and sent to the plasma table for cutting. Click OK to save this change and close the database window. Select Automatic Nesting from the utility bar. The Automatic Nesting window appears. This is a tabbed window interface with many settings and options for nesting. These same settings and options can also be accessed from within the database window. Only the most commonly used and adjusted settings are covered in this lesson. The Help system provides detailed information about each setting and option. The General Nesting tab is selected by default. The first group of settings control margins. The default margin between nested parts is set to 1/2 inch. This setting can be adjusted depending upon the machine type. It is not cumulative between two parts. For most cutting machines, this setting can be made smaller to save material costs. Change this value to 0.25 inches. The additional sheet edge margin is the extra amount of margin around pieces that are next to the edge of the sheet material. This value is also dependent upon the machine type and is cumulative with the previous setting. For this exercise, set this to 0.25 inches. This produces a margin of 0.50 inches along the edge of the sheet material. The new sheet settings determine how automatic nesting reacts when a new sheet is required for the job. Enable the Use Default Sheet Size setting. Nesting uses the default sheet size specified for each material type. Select the Auto Stitching tab. Stitches are short segments of the material along the cut line that are left uncut. This produces small temporary connections between the inner and outer pieces. For example, if a circular hole is to be cut from a sheet of metal and stitches are specified, the circular cut will not be continuous. Stitches connect the inner circle to the outer sheet. Default auto stitching values let you define the size of the stitch and the quantity of stitches to place on the island when the auto stitching is switched on. Stitching is useful when cutting gored elbows. The stitches keep the small parts together for faster assembly. Select the Auto Nest Options tab. The options on this tab determine the methods used by the software to actually nest the parts. The slider at the top of the window controls the degree to which the Auto Nest algorithms attempt to find the most efficient nesting of the selected parts. Faster computers can accomplish more accurate nesting in a given amount of time. Adjust this slider to meet your own needs. Click the Advanced button. The target setting is the ideal material usage efficiency for a sheet of material. The nesting algorithm strives to achieve this value. Accuracy and speed are the trade-off values for nesting. Click Cancel to close this window. Select the Preferences tab. The Nest for Machine setting enables users with more than one cutting machine to determine the preferred machine to which to nest. This is necessary because the software can only nest a job in one way. Select the drop-down menu and note that it lists the 3 machine configurations that were previously created. Select the 10-footer machine configuration as the preferred machine. The preferred part placement options determine how the parts are nested on the sheet. The Across Width of Sheet option attempts to fill the width of the sheet before the length. This is generally the preferred method. The Across Length of Sheet option fills the length before the width. The Smallest Bounding Rectangle option attempts to use the smallest possible area, irrespective of its position on the sheet. Select the Sheet Order tab. The Sheet Order tab determines the order in which the sheets are displayed on the Nests tab within the Job Contents window. When the NC data is written later, these settings have a bearing on how the NC numbers are allocated. The default settings sort the sheets first by sheet nesting priority, then by material, then by gauge, next by the width used, and finally by the length used. These sort items may be changed by adding, removing, or moving the listed items. Select the Method tab. Settings on this tab determine which nesting methods are applied. The options govern the general form of the nest. Nesting is a complex subject and has been the focus of many scientific papers. The 5 nesting methods offered within Fabrication CAMduct represent the most useful and efficient for sheet metal fabrication. The batching setting enables you to nest parts from the same group together. You can select None, Item Section Name, or Item Page Number from the drop-down menu. The True Shape nesting is the default selection. This method uses strips to nest the parts. This method is very accurate. It is the only type of nesting to utilize the settings on the Preferences tab. Row nesting is a good method for one-off symmetrical items. It is not as effective as nesting asymmetrical items. Row nesting cannot be used to nest on remnant sheets. Rectangular nesting creates a minimum bounding rectangle around each part. No other part can encroach into this area. It is best used for nesting rectangular-shaped developments. Edge nesting starts from all four corners of the sheet and simultaneously works towards the center. This can be used to preserve the maximum remnant sheet, but it cannot be used to nest on remnant sheets themselves. NFP nesting, also known as no-fit polygon nesting, is a relatively new algorithm that, in some cases, achieves higher material usage efficiencies, but it is less efficient with oversized parts. Earlier, you enabled insulation cutting in the database. The Nest Insulation Developments option is another on-off setting that controls whether or not insulation is included in the nesting process. For this exercise, disable this setting to nest only metal. You're now ready to nest the items in this job. Click OK to start the AutoNest process. A series of progress dialogues appear. Upon completion, you receive a confirmation that the job has been nested. Click OK to close the dialog. The Nests tab of the Job Contents window appears with graphical representation of the nested parts on sheets. The parts that are nested are metal. Insulation nesting was disabled in the Method tab of the Automatic Nesting window. Each sheet is named Untitled as it has not been written to NC code yet. Select the Write NC button on the utility bar. The Write NC window appears. The Keep Current NC File Numbers option is inactive. This option is used when rewriting NC. It reuses the NC numbers that are already assigned to the sheet. The advantage of this is that any printouts showing the NC number are still valid. The range numbers specify the minimum and maximum NC file numbers. Minimum is set to 1001. The Start At setting is the number of the next NC file to be written. Unless altered manually, this automatically increments from the last NC number created. It is defaulted to 1. NC Batch step is used to separate jobs by NC numbers. Any value specified here is the increment applied between separate write NC operations. This value is set to 10. Some machine controllers require a minimum number of characters in the NC file name. The file name length value sets the number of digits to be specified. It is set to 1. The Write NC for all machines in group enables creation of NC code for machine groups. The Save to Removable Media option enables saving NC code to files for later use or for transport to other fabrication facilities. The default settings are acceptable. Click OK to generate the MC code for these nested sheets. The sheets are renamed to NC numbers matching the NC code files created. Notice that the numbers start with 1001 and increment by 1 for each sheet. The metal parts have been nested with NC code generated. You now nest the insulation for these parts. Click Automatic Nesting on the utility bar. Select the Methods tab and enable Nest Insulation Developments. Fabrication CAMduct does not nest parts that have already been nested and had NC code generated. The AutoNest process skips over the metal parts and only nests the insulation pieces. Click OK and the nesting process starts. Progress dialogues are visible. When the nesting process is finished, you receive a completion confirmation. Click OK to close this dialog. Notice that the nested sheets of insulation are named Untitled. These sheets must have NC code written. Select only the nested sheets named Untitled. You can use the Control key and mouse to select each sheet or use a window crossing technique. With the Untitled sheet selected, right-click and choose Write NC from the shortcut menu. The Write NC window appears. The Start At number has incremented to avoid overwriting existing sheets. The other settings are satisfactory and should not be changed. Click OK to write the NC code for the insulation. All of the sheets are numbered. Double-click on the second nested sheet. It should be named 1002. A warning dialog appears. Any changes made to this nest deletes the corresponding NC code that was generating. Click OK to close this dialog. The manual nesting window appears with this nested sheet displayed. You can make manual changes or edits to the nesting using this window. Click the red X at the top right corner of the window to close the manual nest window. The nested sheet should still be highlighted. Right-click and select View NC on the shortcut menu. It lists both machines that are appropriate for cutting this material. Choose the 10-footer. The NC Reader window appears with this nested sheet displayed. The right pane is the NC Data View pane and displays the actual NC code generated for this nested sheet. On the left is the NC Graphical View pane, which gives a visual representation of the table. This window can simulate the cutting process by showing the tool head path in motion. The display is controlled by the remote control icons on the NC View bar at the top right corner of the window. The controls for viewing the NC work in a similar way to a Blu-ray disc or DVD remote control. Once the simulated tool has been started, statistics appear to the left of the controls. These show the cut length and machining time. Click the forward button on the NC View bar. This button has double arrows pointing to the right. The display shows the motion of the simulated tool head path. Cuts are shown in one color while non-cut movements are shown in another. It simultaneously highlights the active code string for diagnostic purposes. Notice that the total cut length is about 113 feet. Total machine time is 3 minutes and 49 seconds. The time is calculated from specifications entered during the machine tool setup. Click the Job Contents button on the utility bar. Select Nested Sheet number 1024. This is a sheet of insulation material. Right-click and choose View NC 10-footer. Click the Forward Control button on the NC View bar and observe the cutting for the insulation. Whether simulating the cutting of metal or insulation, the display looks the same. Notice that the total cut length is almost 114 feet, but the machine time is only 1 minute and 42 seconds. This is much faster than for the metal. This is because the feed rates or cutting speeds for the two machines are different. Close the job without saving. Some parts are too large to fit onto a single sheet of material. Fabrication CAMduct can automatically or manually slice the part into 2 or more pieces for fabrication. Create a blank job. Select Item Folders from the utility bar. In the search field above the Folders pane, type Transition and click the Search Now button. The first item displayed in the preview pane is the transition in the rectangular folder. Double-click this item to add it to the job. It appears in the Takeoff window. Enter the following sizes for this transition. For dimension A, enter 120 inches. Dimension B is 96 inches. Set dimension C as 96 inches. For dimension D, enter 86 inches. And for dimension E, enter 60 inches. These sizes ensure that the parts for this item are too large to fit on a single sheet of material. Press F7 to redraw the item with these new sizes. Click the Accept button to add this item to the job. A window appears indicating there are 4 oversized parts in this item. The first oversized part is displayed and options are offered to resolve this problem. Oversized options are set in the database. The visual display of the part is shown at the right. It displays proposed splits as dashed lines. Changes to the settings and options to the left dynamically affect this display. The text box in the upper left corner explains the problem and identifies the part number. The Fit to Sheet Size drop-down menu offers the specified sheet sizes for this material. These sheet sizes are set up for each material. The size shown is the default sheet size for this material. Preferences for how the oversized part is to be split are shown at the left. You can select equal part sizes or have it create the largest sizes possible. The Preferences settings control whether you want the fewest number of parts or have all the splits made in the same specified direction. The minimum part size is the smallest part dimension. This prevents very small parts from being generated. The type of seam used for oversized parts may be different from what is normally specified. The seam type affects the flat pattern development. The Use Oversized Seam drop-down menu enables selection of the various seams specified in the database for oversized parts. Once you have made adjustments to these settings, you can choose to apply them to one or all of the oversized parts. You may also choose to ignore the oversized parts condition for one or all parts. You can use Profiler to make manual edits to the part. Make no changes to the settings and click Apply to All. This accepts the suggested splits based upon settings in the database and accepts the parts into the job. Select the Job Contents button on the utility bar. The oversized transition is listed on the job. Notice that this item has 10 parts as indicated in the nested column. The 0 of 10 value means that of the 10 parts in this item, none have been nested yet. Right-click on this item and choose Automatically Nest from the shortcut menu. Although it doesn't matter in this situation, this right-click technique can be used to nest only selected items rather than the entire job. The automatic nesting window appears. The settings have already been adjusted, so click OK to nest this item. The nesting process completes. Click the Items tab to see the job contents. Note that the nested value shows 10 of 10. All the parts have been nested. Right-click on the item and choose Edit Developments from the shortcut menu. You receive a warning dialog. Typically, you want to remove the nested parts when making edits to the flat pattern developments. Changing the flat patterns requires you to nest the parts again to fit on the sheet. For this exercise, select No. The item opens in Opus. You see the outline of the entire panel along with the part that has been split to fit the sheet size. Click the Layout tabs along the bottom of the Opus drawing pane to see the other parts. Each Layout tab has been numbered and named for reference. Close the job without saving. Manual nesting can be used to completely nest all parts or to adjust and modify a generated auto-nest prior to writing NC. Manual Nest provides total control over the way parts are cut. It also contains functions that provide profiling options as applied to an entire sheet rather than individual parts. In this exercise, you learn how to modify a sheet that has been automatically nested. Open manual.nest.maj from the exercise folder. This is a supply air ductwork job that has been nested. Select the Nests tab in the Job Contents window. Double-click the first sheet. It is named 1001. A warning dialog appears. Click OK. The Manual Nest window appears with the nested layout for this sheet. The main view pane is a graphical representation of the table or sheet with the nested parts outlined. Below the utility bar is a ribbon showing all of the individual parts included on this nested sheet. The number in the top left corner of each part is the part number. The number below the part is the blank size. The blank size is the smallest bounding rectangle to contain the part. The blue number in the bottom right corner is the quantity of that particular part left to nest. When a part has been nested onto the sheet, it has a large blue X superimposed over the part. You can change the display so that only unnested parts are shown. Click the View pull-down menu and choose Only Show Remaining Parts. The Parts ribbon clears and you see a message indicating that all parts are nested for this sheet. Pick inside the part at the upper right corner of the sheet. A warning dialog appears. Changes made to the nest deletes the corresponding NC code file. New NC code must be written. Click Yes to continue. Once the selected part is highlighted, click and drag the cursor to move the part on the sheet. Right-click and hold to rotate the part. While the part is still highlighted, press Delete to remove the part from the nested sheet. The part appears on the Parts ribbon. It is no longer nested on this sheet. Click the part on the Part ribbon and a ghosted outline of the part appears on the cursor for placement onto the sheet. Press Escape to cancel placement of the part. Right-click on the part in the Part ribbon. Select Properties from the shortcut menu. The Item Properties window for this part appears. Select the Manufacturing tab. Many of the properties for this part are locked, but some settings can be modified as required. Click Cancel to close this window. Right-click the part again and choose Empty from the shortcut menu. The part is removed from the nested sheet. The Parts ribbon indicates that all parts have been nested. You've removed one part from the nested sheet. Select the Job Contents button on the utility bar. The small graphical representation of sheet 1001 indicates that the part has been removed. The sheet is named Untitled as it has not been written to NC code yet. Right-click on the Untitled sheet and choose Write NC from the shortcut menu. A problem dialog appears telling you that the Manual Nest window must be closed. Click Yes to continue. The Write NC window appears. Verify that the Keep Current NC File Numbers option is selected. This names the sheet the same as before. Click OK. Because multiple machine configurations are available, the Sheet Machining Options window appears. You may choose which machine to use for nesting. The default settings are acceptable. Click OK. If you receive a file overwrite confirmation warning, choose Yes to all. The modified sheet is written to an NC code file. Close the job without saving. The Autodesk Cloud Nesting Service is available to Autodesk subscription customers. The service is accessed directly from within the Fabrication CAMduct software. Open cloud.nest.maj from the Exercise folder. This is an exhaust air ductwork system with about 75 items. Select the Cloud pull-down menu and choose Cloud Nesting. If you're not already logged into your Autodesk account, you're prompted to do so. Once you are logged into your Autodesk account, the Automatic Nesting window appears. The same settings and options you use for auto nesting on your desktop are used in the cloud. The Autodesk Cloud Nesting Service nests using all 5 available nesting methods, and the chosen nesting method on the Method tab of this window is ignored. Click OK and the window closes. The job is uploaded to the Autodesk Cloud Nesting Service. A confirmation dialog appears. Click OK. Select the Cloud pull-down menu and choose Check Status. The Status window appears. This window automatically updates every few seconds, but you can also right-click and select Reload to update the status of your job. As your job progresses, you're informed of the status for each of the 5 different nesting methods. Upon completion of the nesting process, statistics are reported for each method. The sheet quantity is the number of sheets of materials used for nesting this job. Average usage is the material usage efficiency. A higher number is more efficient, resulting in lower material costs. For this job, nesting method 1 is the most efficient and uses less sheets of material than the other methods. Details about each sheet can be examined by clicking the arrow to the left of each method. Select the arrow next to Method 1. Collapse the details by selecting the arrow again. Click the Select Nest link for nesting method number 1. Once a nest has been selected, the method displays a selected indicator. At the bottom of the window, you see a button to merge nest into CAMduct. Select this button and the nesting layouts are downloaded into the job. Select the Nests tab in the Job Contents window to see the nested sheets. Because this is a cloud service, you do not have to open the status window and actively wait for the nesting process to complete. When your nesting job is ready, Autodesk automatically sends you an email notification. You can access your nests and download them at your convenience. These nested jobs are saved and stored in the Autodesk Cloud Nesting Service for 96 hours. Close the job without saving. Nesting is a process that only applies to parts cut on a table. Typically, these are fittings and straight ducts, which are not full length. Full-length straights can be fabricated on decoiler units. These machines measure, cut, and bend the sheet metal at a much lower cost than can be achieved using tables. Some decoiler units can cut and apply insulation. Full-length straights are not nested and no flat patterns are developed. Fabrication CAMduct creates the special NC code that is sent to the decoiler unit. The software knows which items to nest for cutting on tables and which to send to the decoiler unit based upon the pattern or item properties. Pattern number 35 only produces straight ducts to be decoiled. Pattern 866 can produce straight ducts that can be decoiled or sent to the table for cutting. The settings which determine machine cut type are in the database. Open decoiler.maj from the exercise folder. The setting and options which control decoiler unit output are in the database. Select the Database button on the utility bar. In the database window, click Fittings, Pattern Options, and select the Straight tab. The Machine Cut and Decoiler sections contain settings that control which machines cut which parts. Select the pattern switches in the left menu and click the Development tab. The Never Cut Decoiler Insulation option should be set to the capabilities of the decoiler unit. Click Cancel to close this window. Select the Utilities pull-down menu and choose Decoiler Output. The Decoiler Output window appears. The text field at the top identifies which decoiler unit is selected. The file name setting is the path and name that you configured in the Installed Decoiler window earlier. The Output Nested Sheet Blanks option lets you create sheets for the plasma table using the job information. For this tutorial, click the Browse button to change the output file name and path. Browse to the exercise folder and select Save. The new path is displayed. Click OK to write the NC code file for the decoiler unit. A dialog appears informing you that some non-standard straights were found in the job. This warning indicates that these parts were not sent to the decoiler as they do not meet the size requirements. These parts would be nested and sent to the plasma table in a separate operation. Click OK to complete writing the decoiler output. Close the job without saving. Exit Fabrication CAMduct. Using Windows Explorer, browse to the Exercise folder. Right-click on decoiler.dec. This is the decoiler output file. Choose Edit or Open With from the shortcut menu. If no application is associated with the DEC file type, select Notepad. The file opens in Notepad. The decoiler output file is simple text instructions to the decoiler unit. The format and data for each type of decoiler controller differs. Close Notepad without saving.